Let's see if we can get at least one of the DRO axes installed and running today so we can use it to make the rest of the parts. Welcome back to Cloud 42, I'm James. Well, last time we got started making the parts to mount a 4-axis DRO on my new PM-940 milling machine here. And this time I'd like to get enough parts done that we can actually install the X-axis and get it running on the machine. Then we can use the X-axis to make the parts for the Y-axis, and then we can use the X and the Y-axes to make the parts for the Z, and so on. And we can just bootstrap our way through the project, and it'll get easier as we go. Now, you don't have to do that. Of course, you can operate the machine with the hand cranks and the dials. I mean, people have been doing it for 202 years. But it does involve a lot of counting. And let's just say that operating the mill and operating all the cameras and talking to you and trying to count at the same time has proven challenging for me in the past. Let's get started. Okay, the first thing I want to do is take these angle brackets that are used to mount the bridge for the reed head on X and square them up and bring them to width. Actually, the first thing I want to do is put on safety glasses. I would like to thank those of you who remind me down in the comments to wear safety glasses. You probably should remind me a little sooner because after the video is published, it's kind of too late. So these are the same ones that we slapped down on the table and trimmed this leg off, and what I'm going to do is just drop them in the vise and we'll just mill one side and then flip it around, mill the other side, measure them and bring them to width. So I'll just drop a parallel into the vise here, drop one in this side, let it hang over enough. I'll drop the other one in the other side here just to use as a packing block, just so that the vise clamps squarely, though with a brand new Curt, I am imagining it doesn't matter that much. A little snug on that. Okay, the tool I'm going to use here is a long 1/4-inch alu power end mill just to mow through this aluminum. And yes, it is a nice end mill. This has been used, in fact, the last time I used this long end mill, I think, was when I made the dual dial indicator holder for the lathe. But this is long enough to reach down and get the whole edge of the part. And it's in a TTS tool holder because I have a bunch of them there over there in the drawer from when I had the TTS system on my other mill. Now I've just got this in low 1 and I'm just using the resistance of the gear train and the motor to tighten down the drawbar. And then we'll put this in high 3, which is 1970 RPM. And we'll just touch off on the side and just take the edge off, and then I'll I'll bring the other part over and do the same thing. And then we'll flip them around and take them both to the correct. Just trying to think through if I could do this in one setup. Nope. And then we'll flip it around and take it to the correct width. 49.5. I'll take it. Okay, now it's time to cut some slots in these things. Let's start by setting these back up here in the mill. That end mill that I used was, way too long, but I needed it in order to do the reach down. I wish I had like a 3/4 or a 1/2 inch mill with a long enough cutting length, but I don't have one in my toolbox right now, so that's another thing to order. What I'd like to do when I cut these slots is I'd like to set up a couple of datums here just so that I have zeros and can use them. So I'm going to set 1 0 feeding into the back vise jaw, and then I'm going to set up a stop on here as well. So let me grab an edge finder. Then I'm going to set this dial down here to 0. I can barely see it down here under the vise. So to those of you who have commented that this machine seems a little bit low for me, yeah, you're absolutely right. It's definitely a little bit low for me. And that's something I'll be rectifying soon. I'll get some blocks to kind of raise this thing up. But that dial being under the vise, you know, that's not just about being low, that's about just this setup with this vise. And at some point, once the DRO is on, it won't matter. So this vise comes with a stop. And I will just go ahead and grab this and drop it in place. This is just a little stop that comes with the machine. It's got a little dovetail and a little ramp here that will clamp in place, so I can just set it at any point on the jaw back here, turn the screw, and it will lock into this slot on the vise jaw. And then that gives me a place that I can set my part against, and then we'll establish a 0 there as well. Now, this is a 1/2 inch indicator, 500 thou, so we'll need to bring this over 250 and reset the 0, otherwise it'll be off by 50. I am going to use another one of these Alu Power end mills, but I'm going to use a short one. Not really liking how that's drilling. Probably should use an actual drill, huh? And we'll just bring the end mill back in and we'll mow out the material between those holes. And there we go. Okay, we get a shorter parallel, we'll do the other side. And that's the part, it just needs a little bit of deburring. Oh, I almost forgot, there is one more feature that these parts need. They need to be relieved on the back here so that they won't actually collide with the back of the table and drag on it. So back in the mill they go. And there we go. Those are the parts. Look just like the drawing. Okay, the last part we need to make for the X-axis DRO is this bridge bar that just needs to go across the back here. And it goes across on top of the 2 brackets we just made to hold the reed head. And this just needs to be cut to length, exactly 18 inches, and then we need to locate and drill and tap 4 holes in it. Okay, that's one end, all cleaned up, and now I'll just turn it around and I'll use a tape measure for this because I do not have a caliper that will read 18 inches. That is as close as I can see with a tape measure. We're going to call that good. a locking pin or a brake would actually be a very nice addition to this mill. You can get a spline wrench and use that, and I probably will at some point, but I really like on the Bridgeport, so you got a brake handle and you just press the brake handle while you torque it. Now I'm going to start by marking out with a pin approximately where the holes are going to need to be, and then that way we can come back later and only have to use the dials to dial the last 2 digits of the number because we can see where it's supposed to be. Okay, and for this setup, I want to have the whole thing in here and supported so that I can do all the drilling with one operation, but of course these ends are way out here. So instead of setting up a parallel in the vise or trying to do some setup on the table, just going to bring in 1, 2, 3 blocks. And I'm just going to use these to support the ends of the workpiece. So I'll just bring it in here, drop it in the vise, and I'll bring these in so that they'll provide support just inboard of where I'm going to be drilling. So then the vise will provide the majority of the stability. Because this is just a drilling force, it's mostly just going to be forced down. There shouldn't be much vibration. And, of course, I may tap it just a bit to take that out. But I don't want to bend the bar, of course. If I put tension on these, I am bending the bar a little bit, which, is not that big of a deal on this kind of a scale. I just want it to be fairly tight. So I think that will be good enough. And then we just need to locate this. Let me go grab a drill chuck. And for those of you who are keeping score, this is the 1/8 to 5/8 inch drill chuck that I got from Precision Mattnews when I bought the mill. This is the one that took a wild ride in the shipping container. And these are supposed to be plus or minus 7 or 8 tenths run out, which honestly is better than I've seen on any drill chuck I've ever worked with. This one wasn't even close. This was sitting like 3.5 thou total indicated run out. So I talked to Matt at Precision Mattnews. He didn't have this exact model, but what he did is he just sent me a 1/2 inch drill chuck. Now this is hand-picked. He opened it up and tested it before he sent it to me to make sure that it was good, which is good because it does rule out like some problem with my machine that's causing the run out. It also means it's probably not a representative sample, but this thing runs about a 1/2 thou. I put a 1/4 inch ground pin in it, and it ran a 1/2 thou total indicated run out, which is amazing to me for a drill chuck. But take that for what it's worth, and we'll go ahead and use this to drill and tap some holes here. So I've got number 8 drill and an M6x1 spiral point tap. Grab some A9, almost out. This is my favorite lubricant for tapping in aluminum. Okay, and then all the way down at the other end, I'm not going to count, but it should be 17,375. And get close, and we should hit right at 75. In fact, that's it right there. And there we go. Now these 2 holes are M4 by 0.7, so let me grab the drill and tap for that. Just use this little Noga rotary countersink to chamfer the tops of the holes. And there it is. I'll take it over to the buffer as usual and take these burrs off the tips, but that part is done. The next step here is to mount the scale and the reed head to the mill. Now the scale, this is the magnetic scale, the magnetic strip is in here, and you can take this apart and you can cut them and do whatever you want with them. But I'm just going to mount this full length. And the scale has some markings on it. I think you can see here there are these little hash marks. And those hash marks have to be on the same side of the scale as the corresponding hash mark sticker on the reed head. Now, I was originally going to mount this head with the cable exiting this direction, but if I do that, then the hash marks will be on the bottom, meaning I have to flip the scale over this direction, and the writing will be upside down, which presents me with a bit of a choice. Do I want the cable to go where I want it to go, or do I want the writing to be right side up? So I rerouted the cable. And so it doesn't really matter, and I actually kind of like having the cable exit on that side, and if I can find a way to snake the Y through, I think that's what I want anyway, because this mill in general operation is either going to be throwing chips out the front or it throws them out the left side in the rear. And so if I can have fewer cables and less stuff over here, it'll be easy to clean. So the Z scale is over on the right. If I can route the Y cable across and have the X cable go off to the right, then everything will come together, it can be bunched up, it'll be out of the way, and it'll be easier to clean because the vast majority of the chips that this thing throws end up on the floor over here or on this side. Almost none end up on that side, at least so far. So what I need to do is mock this up. And I've done a couple of things. I want to make sure that these screws here on top of the scale that hold down the cover will be below the top surface. So what I've done is I've put the screw in there, and the kit came with a slotted screw. I replaced it with a button head screw. There is a little bit of a compromise here. The button head screw is shorter, so you get better clearance. You can mount the scale higher without it interfering. However, the socket will fill up with debris. And so when I need to take that off at some point in the future, I'll have to clean that out. A slotted head is much easier to clean out because you can just take an awl or a screwdriver and just scrape stuff out. This, you've got to actually lift it out. I don't care, I'm going to take advantage of that. The other thing that I've done is I put 3 washers under this thing and installed the screw. That will make the screw higher than it will be with the scale cover installed. And that way, if I just make sure that this is at the top surface of the table, I'll be pretty much level, and I know I'll be low enough that it won't interfere down the road. So I'm just going to put this on here, and I'm just going to clamp it in place roughly to try to get it where I want it. And then we'll come back and adjust. Now I have a 1, 2, 3 block here, and I'll use this to measure, and I'll basically just raise the scale up until that screw hits the 1, 2, 3 block, and then I know the top of that screw is level with the top of the table. Now the manual suggests mocking all of this up with double stick tape. I have a roll of VHB tape over there I was going to use, and then I realized these clamps will work just as well, and they'll actually be much quicker, and I won't have to worry about peeling it off. Now the other thing that I have here for checking, I think based on the screws we're in about the right place. I also have an indicator set up on a 1, 2, 3 block so that I can come over here and fish around and find the top of the scale. And I'll go ahead and do this over here where you can see it. And let me just bring this down to 0. So the top of the scale there is right about 0. Now normally you would run the table back and forth, but I've already done some testing and I know that this table runs within a thou stop to stop, so I'm just going to roughly do this using the top of the table as a reference, and then we will fine tune it later. The same thing over here, and we are definitely off by quite a bit. Now this doesn't have to be that precise because I will be able to adjust it later after the screws are in, but I want to get as close as I can so that the screws are as close to the perfect position as I can. Okay, so that's 0 and 0, so that is level now. Now we'll leave that where it is and go ahead and try to get the reed head mounted in the right position with the same technique. We'll just use clamps to put it in place. And I've got the reed head already assembled to the bridge with these two angles that we made. And so I will just slide this into position. Move this out of the way. Try to get this up to about the right spot. And then clamp this side piece on. Okay, my goal here is just to get the height approximately correct. And it looks like, and get it approximately centered here. Okay, that looks about right to me. And again, I'm trying to get the reed head centered. We can still move the reed head in and out. Because we have these slotted adjustments, and that looks like we're going to have all the adjustment we need there. So now I just need to mark the positions of everything for drilling holes. I have have some transfer punches here, and I'll try to line these up vertically at about the center of the slot. Okay, those are the holes. Yep, those are nice and clean. It's time to drill. Okay, the scale mounts with M4 by 0.7 screws, and so I've got a number 30 drill here. Now, I honestly don't know how hard this stuff is going to be to drill because this is induction hardened. The way's right underneath it and the table surface right on top of it. And so I don't really know what to expect on the back of the table here. So I'm using a split point 135 degree cobalt drill. Figured that would probably stand up the best to hand drilling in anything really hard. And let's see how it goes. Oh, this is going to go very easily. Okay, and then to tap it, I decided to try to make this as easy on myself as possible. So probably tapping this with a plug tap would have been just fine, but I went ahead and got a set of taper plug and bottoming taps. These are high-speed steel taps, just to make it as easy as possible. The extra step of running the taper tap in first means I won't be taking as much of a chip load, and hopefully that means I will have less chance of breaking a tap. Now you can do cast iron dry. I'm using anchor lube for a couple of reasons. One is it'll bind up the chips, and most of the chips will then come out on the tap as opposed to being stuck in the hole. At least that's the theory. And the taper tap should be a little easier to start straight as well. Okay, let's do the plug tap. I don't think there's any need in this hole to bring out the bottoming tap unless for some reason I can't get the screw in deep enough. Then to clean out the hole, I use compressed air. What I have here is a ball inflator needle, electrical tape to the end of my air gun. What I really wanted was a can of air, but I don't have any, so I put that in the bottom, put a rag around it. And that hole should be pretty much clean. Looks great. Now the next one I need to tap is this over here, and this is, I'll use a number 8 drill because that's going to be an M6x1. And it looks like I'm going to need to move this out of the way. It would seem any concerns I had about this stuff being hard to drill were unfounded. Okay, those are the 2 holes on this side. I will go ahead and tap the other ones, and I'll be right back. Okay, I guess we're ready to install. I did a couple of things while you weren't watching, and because I've been drilling right here and throwing cast iron dust, you can still see it down here, I went ahead and cleaned up the ways of the machine, wiped them down just to make sure there wasn't any of that abrasive dust on there, and then reinstalled the way cover. So we should be ready to go here. I'll grab the screws, and let's just put this thing in place. Put one screw in loosely. Hopefully these screws will line up. Hey, what do you know? It lines up. I'm so glad. And as a rough first estimate on the height, I'll just bring in the 1, 2, 3 block, tick it lightly against it, and then snug this down. Okay, now let's bring back the indicator and make sure we have this completely level. Set that to 0. And we're a little high. Okay, right about 0 there, and right about 0 there. Let's get it, make sure it's tight. Or maybe a 1/10 high if I can even read that. And then in the center, looks like we're about 1.5 thou low, probably just due to gravity, but that's well within tolerance. And we're 0 on that end. Okay, so the scale is now in place. Now let's bring in the read head. The first goal here is just to get the read head at the right height, which should be approximately centered. Okay, that looks pretty good. Now, leveling this up with an indicator is by no means necessary, but What channel did you think you were watching? Okay, those are good. Now the last thing we have to do is adjust the head in and out so that it fits correctly. It's supposed to be a 1/2 millimeter off of the scale, and they provide a handy little plastic shim for this. Which I will slide in from the other direction because it's easier to. I should be able to simply pull the reed head flat against the scale. Gotta make sure my screws are loose. You already knew I had a screw loose. Okay, and we should be able to just tighten these down, and we should be in exactly the right position. And that just pulls out with a little tension on it. That's nice and solid. It's level, it's centered. It travels with the scale. Okay. I think the last thing we need is the cover. Well, we have the X scale installed and we've got the DRO head here. Let's hook it up and see if it works. So X, Y, Z, and U. I'm going to plug this into X. Plug in the power. And let's see what happens. EL404 version 5.0.6. Okay, set to absolute millimeters, and it works. Now I do see that it is moving the opposite direction that I want. It's going positive as I mill to the left, moving the table to the right, and as I mill to the right, it goes negative. That's exactly the opposite of what I want. Let's take a look at the cheat sheet here and see how to change that. Okay, so this says to change the Z-axis count direction. We'll do it for X. Press the setup key, which is the wrench. Press the Z-axis key. I want to select X. Press the enter key once. Should now read linear, it already did. Press the 2 key, which is down 4 times. It says left. And I press the 4 key to take that to right. Continue down. To save changes, press enter. Go down to end, enter. Now what happens? Yep, now as I go to the right, it goes positive, and as I go to the left, it goes negative. That is exactly what I want. Let's see, it's in millimeters, switch that to inches. Now one of the things I was curious about is how precise the inches are. Will it go down to the 10th? Or I guess it's incremented, it looks like it's going 2/10 at a time. Can I hit 0/10? So there's 0. If we go up to 1 inch, I can hit exactly 1 inch. I can hit 2060. Just trying to see if I can actually hit 0, because this is one of the things that I know some people are frustrated with DROs because they, let's go 3 inches. because they actually are metric. This is a 2mm pitch scale, and I was just curious if we could hit even numbered inches. I know some DROs struggle with that. So far it looks good, and if you know of particular combinations that are difficult for a metric scale reading in inches, go ahead and put those down in the comments. I'd be interested in testing, but so far this seems to be working for me. Now, I'm not going to mount this on the machine just yet. I want to wait until I have all 3 axes mounted, I have all the scales, and can figure out the cable routing. And then I do want to mount it on the right-hand side of the column up high, but the Z scale is going to be mounted over there as well, and I want to make sure that it doesn't interfere. So I want to get that mounted and adjusted first. I think that's it for today. The next step will be to make the parts for the Y-axis, and now we have a DRO that we can use to make that a little bit easier, at least on one axis. And we will get to that next time. If you're enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.